This is Project MiROR, modification of iRobot optimized with Raspberry Pi. It is used for the purpose of non-destructive testing. And students done this project are Anuj Pandey, B. Y. Chanvas, R. Madan, R. Rambu. And our objective is to use a commercial small robot which carries one or two sensors to inspect a part of the structure. The robot should offer a possibility self-navigation as well as to follow given inspection trace. The sensor should be adjustable to different inspection traces at different heights from the floor. Example, those sensors should be chosen which open a wide range of applications. Cracks. Cracks are a sign which shows the imperfections of a man-made construction. Cracks are very much possible to happen on both surface and on subsurface defects. So, how do we prevent them? And non-destructive testing. Non-destructive testing is a non-invasive technique for determining the integrity of a material component and structure. Main goal of NDT is to predict or assess the performance and service life of a component or a system at various manufacturing stages. How we overcome the situation? Like we combine the NDT robots and the humans all together, integrated of all these three extremes given us. And the advantages are accessibility, no rocket science involved, economical probability, others. MiROR, the initial and the final upside. iRobot is implemented with Raspberry Pi and integration of iRobot with Raspberry Pi made with two sensor units, laser unit and thermographic sensor unit. And the result is given. How MiROR looks like. It has iRobot at the bottom, scissor lift at the center, and it has thermographic and the laser sensors at the top of it. And it also has an annular ring which gives 360-degree rotation. iRobot. What is iRobot is like? It is a vacuum cleaning machine which we use it for the inspection and it gives mobility to the system. Scissor lift is nothing but which gives a vertical movement and it gives height to the sensors. These are made of aluminum strips, bolts and screws. Grooves are made using CNC machine and the roller mechanism on a similar groove strips. Arduino programming. Arduino programming is nothing but the programming done to the Arduino chip which controls the motors wirelessly using a controller. They drive the whole mechanism, lifting the scissor lift, rotating the annular ring. And Spectrum DX6i, the controller. Spectrum DX6i is an analog controller. It can operate wirelessly up to a distance of 150 meters from the object. So this is a control loop. This is a whole setup of a project which the iRobot and the scissor lifts are controlled by the controller, and it is integrated with the Raspberry Pi to give the certain displayed unit on the output. Testing of motors. The motors controls the scissor lift and the annular ring, and it also controls the iRobot wheel drive. The sensors which we use in our project are thermographic sensors and the laser sensor unit. These sensors are used to find the defects on the surface and the subsurface levels. These are the practical work which we carried out on a connecting rod which shows the thermal image and it shows the defect in the area 1 region. And you can see the temperature change between the defected portion and the outer portion. And this is a calibration of laser sensor. The data processing and the data acquisition of laser sensor are displayed on this screen. This image shows the whole graph in which the data processing is involved. Raspberry Pi. Raspberry Pi is nothing but a microcomputer which has a capability of 700 megahertz and a 512 MB speed RAM. It is initially designed to make computing easier. Limitations of Raspberry Pi. The Raspberry Pi used in this project had some limitations like less processing speed, less RAM, and the operating system. The drivers of the sensors were Windows based and it was not based on the Linux operating system. Suggestions to overcome these limitations are a specifically higher version of microcomputer can be used such as Windows tablet which can run the drivers for the sensors, and hence the sensors can be made working. Conclusion. The conclusion of our project MiROR is proposed use of Raspberry Pi to integrate with the sensors to collect and process outputs was not suitably for these considerably complicated sensor drives. So reason why Raspberry failed to perform is low processor speed, low RAM speed of the Raspberry Pi, lack of source codes for the Windows drivers, Linux based operating system. Thank you.